Hello everyone, and welcome. Today, we're going to talk about a major leap in artificial intelligence, moving from transient, fleeting AI experiences to durable, long-term AI mastery. We will be introducing SkillNet, an open infrastructure designed by OpenKG.cn to build scalable, self-evolving agents. Let's dive in. To understand why we need SkillNet, let's briefly look at how AI knowledge has evolved. In the early symbolic era, systems relied on rigid symbolic logic. While this was highly interpretable, it was notoriously brittle and had limited scalability. Then came the deep learning era, where knowledge became parametric, locked away in high-dimensional weight matrices. This is incredibly powerful but highly opaque, making it difficult to modularize or reuse. Today, we are at the frontier of the agentic era. Here, we are moving toward modular, externalized agent skills that beautifully reconcile structural interpretability with highly scalable representation. But there is a glaring bottleneck right now. Current AI agents keep reinventing the wheel. They fall into the context trap, relying heavily on transient in-context learning or manual prompt engineering. Even though there is a massive amount of valuable expertise sitting out there in GitHub repositories, execution traces, and PDFs, it remains unstructured and unconsolidated. Furthermore, current skill repositories lack rigorous evaluation, leading to stochastic validation and technical debt. Our goal is accumulated mastery. We urgently need a unified mechanism to transform these episodic, isolated experiences into durable, reusable skills. This is exactly why we built SkillNet, an open infrastructure for agent skills. We have built a massive pipeline with over 200,000 total skills extracted, resulting in a curated library of over 150,000 high-quality skills. The core functions of SkillNet are to create, evaluate, and connect AI skills. As you can see from our pipeline, we take raw data like code and execution logs, run it through an extraction and refinement process, systematically evaluate it, and then plug it directly into a searchable SkillNet API. So, what exactly is an agent skill? In our framework, an agent skill is a self-contained package, typically a skill.md file plus necessary resources, that bridges unstructured natural language with structured machine code. It operates in 3 simple steps. First is discovery. Agents load minimal metadata like the name and description to find relevant capabilities. Second is activation. The agent reads the full instructions and prepares the necessary scripts. And third is execution. The agent strictly follows those instructions to execute bundled code or reference specific tools. SkillNet works in 3 phases. Phase 1 is automated skill creation. Instead of manually writing every skill, we use an automated LLM extraction engine to distill heterogeneous human knowledge. We feed it execution trajectories, GitHub repositories, complex documents, and direct user prompts. The engine digests all this information and outputs standardized, executable skill entities. Phase 2 is multidimensional evaluation to ensure absolute reliability. We rigorously test every skill across 5 dimensions: safety against hazardous operations, completeness of prerequisites, verified executability in sandboxed environments, maintainability for backward compatibility, and cost awareness to optimize API usage and latency. This automated evaluation standard is incredibly robust, achieving near-perfect human alignment with a quadratic weighted kappa score of 1.000. Phase 3 focuses on organization using the skill ontology and relation graph. This is a 3-layer architecture. The taxonomy layer categorizes skills from broad domains down to fine-grained tags. The relation graph maps out how these skills interact, tracking dependencies, similarities, and compositions. Finally, the package library physically encapsulates these skill bundles so end agents can easily deploy them. And the results speak for themselves. SkillNet drives massive performance gains. We extensively tested this across diverse environments like ALF World for embodied household tasks, Webshop for online shopping, and Science World for virtual labs. On average, agents equipped with SkillNet achieved a 40% increase in reward, while simultaneously requiring 30% fewer execution steps. Simply put, agents solve tasks much more reliably with shorter, more coherent action trajectories. What makes this even more exciting is that SkillNet offers model-agnostic generalization. We saw massive gains on open-source heavyweights like DeepSeek version 3.2, an impressive plus 28.5 reward bump on frontier proprietary models like Gemini 2.5 Pro, and a plus 15.7 reward bump on compact, high-speed models like O4 Mini. The key takeaway is that SkillNet provides capabilities that perfectly complement a model's built-in parametric knowledge, effectively augmenting pure reasoning with persistent, executable skills. Let's look at how this translates high-level intent into executable action. In an autonomous scientific discovery scenario, SkillNet seamlessly connects data processing, mechanism analysis, and target validation. It automatically schedules specific skills, like accessing database APIs, to generate fully structured research reports. In a coding agent scenario, it connects complexity analysis, component refactoring, and testing loops, allowing the agent to map functional requirements directly to code-level modifications in production-grade codebases. To make this highly accessible, we've built the SkillNet AI developer ecosystem. It provides a unified Python library and CLI tool for seamless integration. With simple commands, you can search for vector-based skills, download them directly into local workspaces, create new structured skills from your own chat logs or code, and evaluate or analyze those skills with multidimensional quality checks. Looking ahead, SkillNet paves the way for truly self-evolving agents. By integrating with frameworks like OpenClaw, we enable lazy loading, where only compact metadata is injected into the prompt until a skill is actually triggered. Agents can engage in proactive discovery, searching the repository dynamically when they face an unfamiliar task. And most importantly, they achieve experience consolidation. Upon solving a complex problem, the agent automatically packages the solution into a skill, evaluates it, and adds it back to the repository. To wrap up, we firmly believe that skills are the bridge to scalable intelligence. Traditional workflows are reliable but too rigid. Neural memory is highly adaptable but lacks operational boundaries. Skills package memory into actionable patterns, making workflows flexible and memory executable. We invite you to explore our repository of over 150,000 skills. Just pip install SkillNet AI or visit our GitHub to join the ecosystem. Thank you for your time.